4.5, translate algebraic expressions. I can translate words into expressions and equations, yes. And when we translate them into equations, we'll look to solve them, but the expressions, we're just gonna leave alone once we get them translated. Remember, another way to look at an expression is kind of like a formula, but expression's good too. All right, translation. We have actually seen this already, and at the bottom we see a little bit of exponent stuff, which is really just another way for repeated multiplication. So cubed is where you have an exponent of 3, squared is an exponent of 2. Okay, so add, the answer for an addition problem is a sum. Looks like the answers for these other 3 at the top. So subtract is a difference, multiply is a product, and divide is a quotient. And as usual, we have to stress these 2 right here because the order for these are direct. For example, if I were to see something like, let's say 3 less 1, that would be the same as writing 3 minus 1. But if I were to see, for some reason, 5 less than 8, then you'd have to start with 8 and then get 5 less than it. So it reverses the order. And it's the same for subtracted from. If we were to see that, then we would say something like 10 subtracted from 12. Okay, that's not too bad. But, once again, it reverses the order into 12 minus 10 instead. Generally speaking, we tend to see one or both of those either on an assignment or on an exam. If we see problems like this, the only thing we have to do is translate. No need to solve because it doesn't have an equal sign for us to solve for. We don't know what this is. Well, I mean, we can translate it. It says like a number. Now, for me, when I see some kind of unknown value, I'm going to use x. I like x because it's just, a couple quick lines like that. Anything else like an a, it's like, whoa, a. It's like a long stroke right there. And since I'm a math nerd, I don't like doing long strokes like that. But 2 quick ones, yeah, that's pretty good. Okay, so this one right here, it says less than. We got 14 less than a number. Now again, since it's a less than, we are expecting subtraction right here. So I can put that in right now. But subtraction order doesn't matter. So we have to think, what are we starting with? Whatever we start with, then we will take a number and subtract it from that. So number start with minus whatever we're going to minus. And this one, it's less than a number. That means that the number that we don't know is the value we're going to start with. So we don't know what it is, which is why we use an x. Well, it says 14 less than that. So we've got to take this, and then we got to go 14 less than it. So then I'll minus 14. That is all. So just a quick emphasis on this. The direct translation would have been 14 minus x. Okay, but this is no good because the order changed. So if you replaced x with any number except 14, you'd get opposites, which we don't want. We want the actual value, like x minus 14. So translate 25 more than a number. How do we know that this one's going to be addition? Because it's more than. So we're definitely expecting some addition right here. 25 more than a number. Now, technically, like if you were to go to some math nerds and be like, this is 25 plus x, they may actually freak out a little bit. Thank goodness the assignment doesn't care because it knows that addition is okay with commutative property, okay? So this one, I'm gonna do it both ways. So you could do it directly and just do 25 minus x. But the truth is, and again, I don't really care, and the assignment doesn't, that it would want you to show that you take some number, which again we're showing as x, and then to have 25 more than it, well again, it doesn't matter where you add it. So technically the second one they would say is better, but I think both are good. All right, so this one I see decreased, which means we are definitely expecting subtraction, but it's not just decreased, it's decreased by 2, right? So again, with subtraction or even division, you got to look at what you start with. So on this one, we're going to start with a number, start with a number, which again, we don't know that value, which means we're going to use an x. And then we're going to decrease it by, so that's where the minus comes in, decrease it by 2. X minus 2. And again, you would not write this one as 2 minus x because you'd get something very different. Now, this one's a little different. How about the sum? So I'm going to start there. Let's take the sum. That's an addition. Now, it says it's the sum of something and something else. So that's where we're going to split the two values that we're going to be summing or adding. The first part is j times 5. So I'm going to take a j and then multiply it by 5. Since I'm a math nerd, I like to see it as a 5j, but technically it doesn't matter. And then I would show the addition. Well, what are we adding? The other value, 14. So we can do it like this. And yes, you could switch it. You could do 14 plus 5j or 14 plus j times 5. It's not going to matter. But I'm going to leave it as is, because that's more writing than I want to do. The difference of 8 times a number and 12, we're going to translate it. Take a minute and try this one out. So yes, this one is a difference, which means we are looking at subtraction. It should be a direct translation here. So what are we subtracting? Well, you got something and something else. You got something and something else. So again, the add is going to split the two values that are being subtracted. It looks like we're going to start with 8 times the number. Now that's going to work out nice because I'm just going to show it as 8x. And then the other value that we're subtracting is 12. Boom. And we'll do this one together. 9 times the difference of t and 7. Okay. So on this one, I've got to take 9. Whoops. I'm going to take 9, so let's put the 9 out there. It says that we're going to times it. Okay, so I'm going to put the multiplication symbol here, even though I'm kind of going to get rid of it. Well, we got to take 9 times a difference. Okay, so a difference, of course, is subtraction. Now, that may seem weird the way that I have this written. It's 9 times a difference. Okay, so what this means then is that the difference is going to be between two values. So I'm going to put in parentheses with my subtraction sign to show that I need that difference, and then I can multiply it by 9. Kind of like order of operations, right? Well, what is the difference of? Well, it's the difference of something and something else. So the and is separating those two values. The first one I'm going to say is t, although I'd like to use x. T is pretty good. And the other value is 7. A difference is going to be automatically a direct translation. Start with t and then subtract the 7. Now this is good. Like you can keep the multiplication symbol right there, or if you really wanted to, you could be nerdy about it and take it away. Doesn't matter. What we have here is what we want. Speaking, this is the kind that students get tripped up on, and this is usually a type that not only will we see on an exam, but also a final as well. There's a similarity. Okay, so I'm going to show a similarity here. But I'm going to use the same values, okay? So I'm going to take the words. It's almost exactly the same words, just slightly different. So what we would do is we would want the difference of 9 times, all right, 9 times t and 7. How about that? These look almost exactly the same. So again, when you do these, make sure you take your time and really read them so that you can figure out what's happening, because on the second one, the second example, you've got a difference first so that we would show the subtraction. And then again, it's splitting, kind of like that last example we did. It's splitting these two values. You've got a 9 times a t, or 9t, and then the 7. Okay, so this one doesn't have parentheses because it's a difference of 9 times something and something else. This one, it's 9 times a difference, which is different. No pun intended. The World Economic Friends charge $15,000 for adult admissions and $10,000 for each child. Write an algebraic expression to represent this situation. Let C represent the number of children and A represent the number of adults attending the field trip. Oh, that's a field trip. It's quite an expensive field trip. In any case, so This one, we have two different values that we need to include in our expression. All right, so I'm going to start just what it starts with at the top. It says at the top here, you got $15,000. That's an adult admission. So if I put in 15,000, that's how much I would pay for one individual adult. So I'm going to start with adults here. Okay, but we don't know how many adults are going. It said over here, use A to represent the number of adults. Well, I don't know how many adults, so I have to use A, some kind of variable. And essentially what we're doing is we're creating our own formula for the cost of how much it would go, how much it would be to go to this World Economic Friends place. But then it says you got $10,000 for a child. So again, we got two different types of people going. You got adults and children. For a child to go, it's going to be $10,000. But then again, they said use C to represent the number of children because that's for one child. We don't know how many children are going. So yeah, so there's a C. And since we are looking for this expression, which I'm just going to label it as kind of like a total cost to go to this World Economic Friends place, we're going to add those two together. That's it. That's all we're going to do. Well, you and Mr. Garrison were driving to a meeting 587 miles from their office. Whatever. You drove the first T miles, then Mr. Garrison drove the rest of the way. Right now, algebraic expression for how many miles you drove in terms of T. So this one's kind of like the last one. We're not actually solving it, just like we have just been translating. So we're just translating this into an algebraic expression. But they told us which variable to use. And you got two people driving, right? So you have first, we'll say you. And then, since Mr. Garrison's kind of a long name, I'm going to put that down here, just copy and paste. I don't want to write that much. So in terms of driving, if I were to take these two values and add them together, that would tell me the total amount of driving that took place. So the addition is kind of to represent a total driving. Maybe that doesn't sound, like total distance, whatever. In any case, it says that you are going to drive T miles. We don't know how many miles you drove, so we're just going to put a T. It kind of looks like a plus sign. Then we're going to add Mr. Garrison's driving. We're driving. Oh, okay. This is what happens when you don't read the problem completely, because they didn't tell us how much Mr. Garrison drove either. Yeah. But what we do know is how. Here we go. What we do know is how much total driving took place. Let's change this up just a little bit. So I'm going to do this on the right. We want total. We're going to look at total miles driven because that was a value that was given to us. It was given to us. You were driving a total of 587 miles from the office. Okay, so I'm going to put that in. So you're going to start at your office. You're going to go 587 miles. You have to start 587 miles to go. Now you're going to drive some of those miles. What's the question? Because I should have read that already. Then Mr. Garrison, write an algebraic expression for how many miles you drove in terms of T. Okay, if I were to read that last part, write an algebraic expression for how many miles you drove. It says up there you drove T miles, so I think T is just kind of the answer there. Let's change this so it's not I don't know, redundant. Let's change this a little bit. We're gonna change you into Mr. Dredd. We want to know how many miles Mr. Garrison drove. Okay, so you got total miles, and this would be how much miles did Mr. Garrison drive of that 587? Well, we don't know how many miles Mr. Garrison drove, but we know if we were to take your mileage and take it away from the 587, so you are going to drive T miles, trying to make that the same color, like this. So total miles minus how many miles you drove. This would tell us how many miles Mr. Garrison drove, which means that, again, the wording of this was kind of jacked up, but we changed it to make it, I don't know, maybe a little bit more applicable. Well, this brings us to translating equations, which if we do translate an equation, then we will also solve it. So the word is usually used to make an equal sign, but sometimes they'll just say outright equals, is the same as, equals to, equivalent, results in. Any one of these could be used, but usually is the one that is used. And sometimes they'll tell us we're going to use an equal sign by telling us or stating that we're looking for the answer for a specific type of operation, like addition answer is a sum, subtraction answer is a difference, multiplication answer is a product, and division answer is a quotient. So they may not even say it equals, it's just that they're going to say it's a sum of, or a difference of, or product, and then we know that we're looking for something that it is, equals, and then we will put the equal sign in there. It is a fraction, but, and there's actually several different ways to write a fraction out in words, but what I'm going to do is I'm going to look at this fraction line as a division sign instead. So that would read, and again, I'm not writing it yet, but I will, that reads 72 divided by x is, or equals, -6. So let's see if we can get this in. 72, okay, there's the 72, that's the numerator, divided by, now you could just say over, which is another way to say it's a fraction, but divided by as well. Divided by x, I'll put equals to, equals, well, just equals, -6, boom. No need to make this more complicated than it needs to, like, x goes into 72 or 70, however that would be worded. But if you get subtraction or division, don't worry about doing that opposite thing. Just translate it directly and be done. Translate and solve. -16 is 24 less than 18 times the number. Take 30 seconds or a minute and see if you can translate and solve this one. Let's start with just the translation, right? Now the word is an important word now that we're solving because we're looking for equal signs. Is should represent an equal sign. Well, it says it's -16 is, so that's, I'm just gonna put the -16 equals. That's that first, just the first two parts there, we translated it, bam. Now the next part, 24 less than 8 times the number. The less than is gonna be important because it's gonna switch the two, the order. But I do know that less than is going to result in a minus. Okay, so again, it has to be, since it's a less than statement, we gotta be careful with what we're starting with, right? So it's less than what you start with, and so this is what we're going to start with right here. And that is 8 times the number. So 8 times the number I'm going to show is 8x. Then it's 24 less than that. So that's where the 24 comes in, 8x minus 24. Now, if you make a mistake, if you had written those backwards or misplaced the x, I mean, that happens since this is new. But we have to be careful on these because if we do get the order, if we get the order wrong, then we're likely to go wrong, which we would. So if you wanted to, you could have written it to just 8x. I'll keep it color coded, minus 24 equals -16. This would work. I kept it like this just to keep it more of a direct translation. So let's go through, and again, I'm just going to focus on this one. We're going to use principles of equality because there is no distribution. We're combining like terms needed, which is convenient. So my first principle of equality, I've got my 8x on the right. There are no other x's, so I don't have to decide. I just want to zero that out so that I can get that 8x by itself. So that, I would treat that as -24 plus 24. If I do it to one side, I got to do the other side. Okay, so that's going to allow me to take that 8x and drop it, which is actually part of the plan. On the left side, -16 plus 24. So we're adding from that negative. They're opposite signs you could look at, and we have more positives than negatives. Okay, well, how positive is the answer going to be? Take the big numbers, subtract the small one. We'll make that 14 minus 6, which is 8. 8. We drop the 8x, and the -24 zeroes out with the plus 24. Last thing we're going to do is make that coefficient of x a 1. We want this to be 1x, not 8x's. So we'll take both sides and divide by the coefficient, which is the red 8, not the blue one. So this 8 divided by 8 is 1. 8 divided by 8 on the left is also 1. That's it. Now we can check, right? Because 8 times 1 is 8, which is this value. 8 minus 24 is negative 16. Yep, that checks off. We did it. 5 subtracted from the quotient of a number and 8 is negative 21. So it says we got to take 5 subtracted from. Okay, so subtracted from, of course, is just subtraction. But whatever we're subtracting, we got to take 5 away from what we start with. So this is going to be minus a 5. Okay, so the other value, the first value, the value we start with is a quotient of things. We got a number and 8. Now let me say the number is x. We don't know what it is, and 8. I'm going to show the division as a fraction line. So you can think, I'm going to come back to that, but you can think if I show this as x divided by 8 like this, that can be a little confusing. Even though order of operations would say, yeah, you've got to do the division first and then the subtraction second. But what are we dividing? Well, we don't know what x is, which is why, in my opinion, I think that the fraction is going to be better for us as much as fractions are hated.
Right.
That's just me.
Yeah.
Is the equal sign. It is negative 21. So you'd put that in the first box on the assignment, and then on paper you'd need to simplify or solve this. So principle of equality, right? No parentheses, no combined like terms. Let's get that x over 8 all by itself, right? Because I'd like to be able to just take it and drop it. But if I do that, I've got to get rid of that negative 5, so I'm going to have to add 5 to both sides. So we already dropped the x over 8. Negative 5 plus 5 is 0. That's part of the plan. We're adding opposites on the right side of the equal sign. There's more negatives than positives, so I know the answer is going to be negative. Take the big numbers, subtract the small one. So we'll make that 11 minus 5 is 6. Drop the 1. Negative 16. Now at this point, even if you had divide by 8, then you would know that you'd need to be creating a 1, which we do need. But it may not be so obvious that you need to multiply by 8, which is why I like the fraction. So going with the fraction then. Here, in order to make this a 1x and not x over 8, or an eighth of an x, another way to say that is we would need 8 of those, which is why we multiply by 8. If I do it to one side, I must do it to the other side as well. So the 8 divided by 8 there is going to be a 1. Now that's crossed out, but it's a 1. It's just slanted. And then a negative times a positive on the right will be a negative. Then we would do 16 times 8. So 8 times 6 is 48, carry the 4. 8 times 1 is 8, plus 4 is 12. So we end up with negative 128. Now we can go backwards. You can take negative 128 divided by 8, and you get negative 16. And negative 16 minus 5 is negative 21. So that's going to check off, which means we found the solution. That's 4.5. Translating and solving, well, translating and solving equations, but just straight translating expressions. Boom.